Hello everyone, it's September 19th. Alright, let's get right into it. Maximum length of repeated subarray. Maximum length of repeated subarray. Given two integers, nums1, nums2 array, return the maximum length of a subarray that appears in both array. Isn't that just the maximum length, maximum subarray? 3, 2, 1. This is a classic maximum longest common subarray, LCS. What do you mean by repeated? Subarray that appears in both arrays. It's just LCS. I think this is just LCS. I think I still know how to do LCS. I will go top down. Usually LCS top down is easier to do top down. So we have index. So I and j. I return. Oh, how do you return the longest? You have to mark it. Yeah, I think you have to mark it. Yeah, that's actually harder if you want to return the longest common subsequence. You can get the value, you can get the length, but if you want to get what it is, you have to mark. Yeah, but in this one, you don't have to. So basically we say nm lenums1 and lenums2. Alright. I think if I is equal to m, switch this. I is m or j is n, return 0. Otherwise, we say if they're the same, right? If the two are the same, then we're going to return. Oh, this one's actually have to think about it differently. If they're not the same. Wow, actually I don't know how to do top down. Let's do bottom up. Oh man, honestly I don't know. And bottom up is more intuitive for me. Actually, we need to do n plus 1. Okay, so we can say for I in range 1 to m, well actually n plus 1, j in range 1 to n plus 1, right? So if they're the same, right, if nums1, I minus 1 is equal to nums2, j minus 1, if these two are the same, then I say dp ij shall equal to dpi minus 1, j minus 1 plus 1, else dpij shall equal to the maximum of dpi j minus 1 or dpi minus 1 j. Now once we're done, we'll return dp minus 1 minus 1. Okay, let's try this. Find nums2. Oof. Nope. You screwed up, man. Find length. Num2 is not defined. That's nums2. Alright, I just submit it. See how it goes. Oh, that's interesting. Is this a new test case? Expected 2. 0, 1. Why are you saying 3? That is interesting. So this is 0, right? And then so I is num1. Then we go j. So the first row. This is 0, and then we go to the 0. Alright, so that's 1. And this 1 is 1. That's, yeah, so, Then 1, 2, 3. 1, 2, 3, 4. 3, 1, 1, 2, 3, 4. 1, 2, 3, 4. So we're talking about from this to this and this to this. We have 0, 1, yes. And then, oh, this is not right. If they're the same, if they're the same, it's I minus 1, j minus 1. Zero, 1, 1. 0, 1, 1. Oh, what's the subarrays? We have 0, 1, 1. This is also 0, 1, 1. Wait, hold on. Did I understand the question wrong? Oh, wait, hold on. Let me read the question again. How is this one wrong? That a subarray that appears in both arrays. Oh, subarray! Not subsequence. Come on, man. Come on. What the hell is this? Seriously, what the hell is this? Subarray. Dude, come on. Subarray. Gosh. I am so sorry. I apologize. This is embarrassing. Subarray. Dude. Okay. Now we do subarray. And how do we do subarray? We will do But I can do similar, right? We just say, yeah, like this is the same as LCS, but no, it's not the same. So we say at a certain point we want to say what's the maximum length of subarray that's ending at this position, right? So we say if these two are not the same, then it should be this and this, makes sense, or this and this. If they are the same, I think that's one. If they are the same, like if they are the same, then subarray. If they're not the same, right? Say these two, they're not the same. Then up into here shall be this fit into this. What's the maximum subarray? But it has to ending at this position, right? It has to end at this position. So what we try to say is the maximum subarray ending at each position, okay? Ending at this position. So if they're not the same, then there's nothing. If they are the same, then we go back. So I feel like this shall be easier, right? So let's just say an I. So just say if they are the same, then will be this. Else, then we don't even do it. Something like this. Then it will be 1. Oh, then it has to be the largest. Now it's interesting. So everything, if they're the same, right? So we just compare if they're the same, because if they're not the same, it's just going to be 0. We're not going to change anything. So if the two are the same, then we need to do -1, which means going back and then going up. So if we do this, then, going back. This rule even changed. But if we go on this position, right? Because initially it's all 0. And then the first row, let's say if I have, I'll try to do 1D. Like I have these values, and they're J, and then J and J start from here. Say if I do the same, so this shall equal to basically this. Maybe it works. I don't know. So say this is the same, then say dpj equals dpj minus 1. Alright, and then once we're done, we say res equals maximum dp and then res. And then we return res. Sorry, it should be max. Yep, I feel like this is the one. Yeah, because it's going to change. Oof. That's very interesting. How? The last one is 5. What the hell? So J is 1. So anyway, we just go from this to this. I mean, I doesn't even have to. Basically, we're saying 1, 2, 3, 4, 1, 2, 3, 4, 5. The last one. That's 1. That's 2. That's 3. Then this should be 0. Oof. Then else dpj equal to 0. No. dpj 0 is not right. Huh? Hold on. If the two are not the same, right? I is this, and j will just go. If they're the same, right? Then we do the previous plus 1. If they're not the same, so up until this point, what's the longest? Well, if they're not the same, then I would say just dpj minus 1. Let's see. If they're not the same, then the maximum, then it's not, is the maximum until this point. The maximum until this point. Not ending in this, just maximum until this point. But then how can you plus 1? Then you cannot plus 1. Yeah, this is not right. This is not right. It has to be 0. Because if they're not the same, hold on, let me think again. If these two are the same, then we say this will be plus 1, right? If they're not the same, this and this are not the same, that means ending in this is 0. Then we fail. We fail horrifyingly. Let me think again. What we're trying to do? What we're trying to do is saying from I to j, right, in this range, what's the maximum ending this? So we say if these two are the same, then we go the one previous plus 1. It makes sense. Oh, I think I know. We're supposed to go from n to, we're supposed to go backwards. Yeah, we're supposed to go backwards. Don't forget, supposed to go backwards so that we don't overwrite the values that haven't been used. Yeah, that's the problem. Yeah, like the logic seems correct. Man, I am not happy with this. But with this, can I just go DP? I don't think so. Man, I don't think so. Yeah, I think we have to do it this way. All right. I think this should be the same method, but I'll be very surprised that the methods will be different. But anyway, man, this really threw me off. Multiple mistakes. Okay, multiple mistakes. First of all, I thought it was about subsequence. So I coded up LCS, but was marvelously wrong. Then I tried to code 1D DP directly, but got hit by the direction to not overwrite the values that haven't been used. One must go from right to left on each DP run. But other than that, it's basically the same. All right, let's see. This is 55 test cases. Oh, so there was a better solution. 57, so we got 2 more, but the runtime is bad. A binary search. Binary search. On the length? Oh. Oh, you gotta be kidding me. Oh, wow. Binary search. That is a pretty gnarly solution. Default dict. Default dict. Huh. Oh, I'm jumping. I am jumping. I see what I did there. I'm jumping forward. I map it such that I just go from, yeah, it is correct. Yeah, this actually might be faster. But this is just one DDP. I don't want to spend too much time on this, but I want to really take a look at the binary search. Yeah, DP works, sure. Oh, rolling hash, jeez, God. Sliding window. Oh, robbing card. I forgot robbing card already. Ah. Yeah, it's a rolling hash. So basically we binary search on the length. No, I'm not rolling hash it. I'm just going to do binary search. Binary search, courtesy of my solution last year. Okay, so yeah, when is a def check? Length L, a boolean value. Basically, we're just saying I'm gonna go through every single one and to see if they match. So the goal is to obtain all sub-array substring of size L. Oh, that's why you want rolling hash. Yeah, I want to avoid using rolling hash. But anyway, maybe we should use rolling hash. Okay, let's read this again. P to the I times si. This is a robbing card. Hash this. I plus guessing linear time. We'll also use a fat dead. I mean, we can just get a hash that goes from first, right? Because we're going to start from the first, and every time we get sliding window it. What's this pinv? Pinv? P inverse. I'll just divide it by p. Multiply by p and minus 1 times x. What's your p? 113. So every time we do this, with a rolling hash, courtesy of official solution hashes. I want index, yeah, this is the length. Guess, yes, guess is to obtain all substring of size guess from nums1, not substring, subarray, and nums2, obtain hashes, hashes of all subarray of size from nums1 and nums2, and check whether any of the hashes match. Yes, that's our goal. So we need a big prime number. How do you 113? Mod. Do we mod? They do mod. And let's not mod, see what happens. So we're gonna say, so we're gonna always start, right? With a certain distance, a length. We don't have hashes. We just go straight ahead because the guess, each guess appears once. So I don't think I need this. I just need this, right? And then hash h1, right? Start with 0, and then guess. Yeah, I think I'll just compute. Yeah, so we say for I in range, guess h1 plus equal to, right, h1 plus equal to p to the I. So p to the I plus, I can just extend it. What's this n? And here is just x just times power. X times power. What? Divided by p plus Pn minus 1 times x. What is this n? Alright, we need to learn a rolling hash. I mean, we learned it in the past. Just kept forgetting. Because I don't use it. Okay? I just don't use it. This is not helping. Minus this times 5 plus d times 5 to the 0. I can find an x hashing O1. Okay? Hash h. Input characters. A is a constant. A usually is a what's that thing I was thinking about? Prime number. No, m is a large prime number. Okay, m is a large prime number. Is h as the previous one minus c1 as the first one times a to the k minus 1 times a plus c k plus 1 times a. That's always is 1. What the hell is this? P power times p. Oh, I think what this one is, we go, I don't understand. This is just increase on the power, but you go from start to end and you get the value, right? Multiplied by the power. Like, what the hell is this? This power starts with 1. And you start from this one. Are you saying you put A0 at the front? But that didn't make no sense, right? Huh. Yeah, I don't understand this one. You start with 0, and your first character, or just times, the first character is just the first one. We don't even time another one. And then the next character, the power goes up. Next character power goes up. Go to the last one. We have the maximum power. That's the opposite of what this is. Doesn't make any sense, man. Doesn't make any sense. I need a better source for the rolling hash. This doesn't make any sense. Now this makes more sense if you do it this way. Okay, this makes more sense. How about the compute a new one? Okay, here. At some index. Why are you divided by p though? That's also something I don't understand. You shouldn't, right? You shouldn't divide it by p. It should just be hash minus s0. Oh, you need to divide by p. I see. Oh, n is the length. Okay, okay. Now it makes sense. Now it makes sense. Then p minus 1 is pm minus 2 mod m. What? This does not make any sense. But you do have to divide by p and then plus a new thing. Okay, so now it makes sense. Okay, now these all make sense. So now what? As a p inverse. So with this minus h is the hash. And we'll minus this, then times p inverse, then mod. I don't understand. Don't understand. Why do you do this? Oh, this is just minus this value. Oh, this is just minus the value. Okay, now it makes sense. Divided by p, which is the same as multiplied by p inverse, and we mod. Then the plus the power times x. Oh, the power has to keep going. Power has to keep going. But why the power is keep going though? Why? Shall we just remove this and then multiply the new thing? Yeah, that's also something I don't understand. I'm gonna do it my way, which involves just this. I probably need mod. Alright. And we just get a first guess what you're going to be. And we're going to avoid. So we say power equals 1, right? So h1 equals plus equals nums1 I, right? This one times power. Well, I should say h1 plus this, say mod, and power equals power times p. Something like this. Yeah. This is number 1. So we get a first for number 1. And then we'll go through everything in num1 to obtain everything in num1, and then we got num2. We're gonna go through everything, and every time we're gonna check a num1, see if it exists, right? And we have to check every single one. We have to check because we might have collision. Yes, so I'm gonna have to say num1 hashes, right? Default dict IC. Now I see what this one is. Default dict. So what we do, we get, this is the hash, and then we say nums1 h1 dot append I. No, dot append 0. We start with 0. Then we say for I in range 1 to len nums1. I'm pretty sure it's minus guess. Right? Then what do we do? So for each one, we're going to say h1 minus nums1 minus nums1 I. No, I minus 1. Right, this one minus this, the whole thing divided by p, then plus power nums1 I plus guess minus 1. Right? And think. So if it's 3, okay, 1, 2, 3, 4, 5. If this is 1, 2, 3, 4, right, 0. So I is here, I minus 1, I plus 3, 1, 2, 3, minus 1. Yeah, it's a new one. So we're gonna plus nums1 I plus guess minus 1 multiplied by power, and h1 will equal to this mod and nums1 hash h1 dot append I until we go to the end. Right. So I feel like this should be +1. So we get this. And then what? Then we go with hash the other hash. So we have to have hash. Yeah, it's fine. Okay, so we're gonna do hash dang it. Nums and guess length turn integer. Yeah, we can just do this one. Oh, we return two things and also power. So we return a tuple. Okay. So we're gonna say h power. We don't need this. Guess h equals to h plus nums I and power and a mod, and I'm gonna return h and power. Okay, so we then have the hash. Then we can say h1 power equals hash nums1 guess. Then we get this, get everything. Okay, now we can say h2 power equals hash nums2 and a guess. Okay, so that's the second one. Then we just say for j in range 1 line nums2 minus guess plus 1 h2 So I have to check h2 as well. How about we first check? Let's check the previous. Then we get a current. Then we have to check again at the end. Okay. Yeah, let's just say if h2 oh man. I see why you want to do it. in the other way. Yeah, it is much simpler. So now I have to repeat. All right. I'm gonna go from 0. If j is 0, else same thing. 2j. Oh, I think this is a capitalized P. Capitalized P. That's fine. The two powers should be the same. Okay, then we say for I in nums1 hashes get h2, right? Well, these are the hashes the same. Then we're gonna compare. All right, now we're gonna compare. Then we say if any, return true. So for we have I, we have j, right? These are the starting point. So we just say I will have all these. Oh, okay, just that's not that. So for I in this, we'll say if nums1 I plus guess equal to nums2 j plus guess, that return true. So this we can say if any and then this, right? If any, then we return true. Otherwise, we just keep going. So we go everything, that's gonna return false. Okay, so that's check. Now we're gonna go binary search. Low, high is 0. Line nums1 minus 1. Did they say the two are the same? No, they didn't say the two are the same. They did not say the two are the same. Which is fine because it's 1000. So we actually just go with 1000. So while low smaller than high, mid equals low plus high, divided by 2. And then we say if check mid. If it's true with this line, then we're trying to go bigger, right? So low equals mid plus 1, else high equals mid. And then I'm going to return. So eventually I say check is true, low equals mid plus high, then false, right? Or high equals mid, then check become true. That is false. Then we go down. Then whenever true, we go this. So the only time it's going to jump out is low go high. So it will be low minus 1. I'm not sure. It feels very... Tuple is not defined. Guess is not defined. Where? What do you mean guess is not defined? Guess is here. Oh, this is not guess. This is length. Index out of range. Where? Oopsie doozy, of course. High should be the maximum of len nums 1 and len nums 2. Alright, that is not right. Yeah, I think it's the rolling hash. Most definitely is rolling hash. Yeah, I don't know. It'll be hard to debug. Print num1 hashes. Wow. That'll be tough to do. You know what? Why don't we, I don't know. Let's say print hash. Let's say low and high. All right. And say low and high plus 1. All right. Which is, that's fine. So every time hash low is be 0, high will be guess. It's okay. Low is 0, high is guess. So I just want to see hash. Let's say nums 1. Right. Low is 0. Oh, as high as guess. No, it should be guess minus 1. High is 2. Nums 2. No, it's not 0. 0, 1, 2. 3, 4. 2 to 4. And 0 to 0, 1, 2. 0 to 2. They are the same. Okay? They're the same. So it is totally unreasonable that this one will be wrong. Because the rolling hash seems to be working. Seems to be working. But if we run, it gives me nothing. So what we can do, let's see, let's just print guess nums1 hashes. Guess never go to 3. What? Yo, man, that doesn't make any sense. The guess never go to 3. It's a 0, 1, and 2. How? 5, right? This is 5. So 0 and 5. That's 2. And then for 2, we didn't find any. No, for 2 we should find. 4, 4, yeah. h2. Let's print h2 and j and h2. Cannot see. All right, so that is very strange. 0, 1. I'd expect 2, 1 to be equal to 1, 2, 9, 9, 7. Power is correct. Okay. Power is correct. I think this is also right. So the problem is here. Oh, Lord, it's J. All right. Still not right. But we fixed one thing. So it should be J plus guess minus 1. So nums 2, nums 2. Power is the same. Yeah, I don't understand. Why would this one keep going bigger and bigger? So what's 2, 1? 2, 1. 3, 0, 1. Yeah, this and this are not the same. 1, 2, 3. 3, 4. 1 to 2. 1, 1, 5. Hmm? What? Start with 1. Okay, now we have P. Next times P. Now P squared, the next one otherwise. So hold on, I think this one should be divided by P. Alright. Now we're talking. Now we're talking. It should be divided by P. Let me remove this. Remove this. And remove this. Okay. Right on all the others except for this one. 4. Maybe we go +1. Have to be bigger. Okay. Rolling hash. Let's see. Nope. Got a wrong answer. Expected 9. Eight, 9. Oh, they're of different size. Damn. Oh, the power should be the same. Y minus 7. One, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, hold on. Wait, what? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It is fine. So this part shall match this part. What happened? What happened? Why 9 is not right? The heck? Guess nums1 hashes. H2. Guesses. We never go to 9. That is bonkers. What? We start with 5. Yes, we start with 5. And then we go to 8. Then we go to 7. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 8. 8 shall be right. Here we have 0, 8, 0, 1. This thing. 1, 2, 3, 4, 5, 6. No, it's from start. 0. 6, 7, 8. That's 8. So the 1 shall be able to match, but 1 does not match. What the hell? Does not match. I don't understand. Is it because of mod? That's fine, because if it's mod, we'll handle the collision already. One's 1, 0. Let's go 0 to 8. That's 9. Let's go 0 to 7. And so hash nums 2, 1 to 8. Right, 1, 2, 3, 4, 5, 6, 7, 8. Nums 2. They're supposed to be the same. They are the same. See that? They are the same. Oh, that's 7. No, that's 8. But a guess length is 7. What? What? 7. Guess length is 7. 7 minus 1 is 6. Oh, yeah, it is the same. If you do 6, yeah, it is. Because they are all 0, 2, 3, 4, 5, 6. Because it's a 0. It's a 0. So it is the same. And if we do this, they're also the same, right? So it's a 0. Okay, so how about 0 to 7? 0, 1, 2, 3, 4, 5, 6, 7. 0 to 7 is different. Okay. How about 1 to 8? Oh, we know 1 to 8. We know 1 to 8 is right. But this is not correct. I don't know why. I mean, in this case, the 0 is also not right. This is wrong, right? If you think about it, if we do 0 to 7, we're supposed to get this. Oh, no, that's right. And then we say this minus 0, basically. Then we divide it by p. And then plus 0, 1, 2, 3, 4, 5, 6, 7. It shall be just divided by p. So 0. Could be the mod. Yeah, I think it's mod. I think it's mod is playing with us. So if we get rid of the mod, I think it will be right. There we go. It's the mod. Holy crap. That's gonna take a long time. Okay, let's do it without mod. See how it goes. Damn, we're talking about large numbers, man. Like, seriously. Large numbers. Yeah, this is not gonna be fast. So, without mod. Because the division is the thing. Screw you, division. What if we go from right to left? Yeah. Why don't we go right to left? If we go right to left, then we just change this. Right? We still do this, but we're gonna go high to low. Same thing, right? And then this will change. This will be MN. I just want to avoid doing doing the other thing. So I think this I can mod. It's okay. And then this will be m minus 1 to 0, right? M minus 1. That's the thing. And then here is going to be m minus 1 to, damn, guess. Is the last one, right? Well, we do minus 1, so it's not gonna reach, guess, because it's a 1 to 0. It reached the one before, so this is actually has to be guess minus 1. Let's see, 2, 3. So if I say 3, then I need to go here, 0, 1, 2. I need to reach 2. It's actually minus 2. Okay, so h1. Now this will be interesting. So we're saying this is 0. We start here 0, 1, 2, 3, blah blah blah, and then we remove this. Ah man, I think it's the same thing. No, it's the same thing. No, it's the same thing. I have to remove the front. Oh, let me think again. What if we do this? 0, 1, 2, and minus 1. Right, but then we go this way. We remove this, multiply by p, and plus. Yes. So this, we still go low to high. This one doesn't change. Still low to high. This is the same. And this needs to change. What's low? High is m minus 1. That's high. Low will be m minus guess. M, let's say m is 5 minus 3 equals 2. Yep. So we start with this, and I'm going to do m minus guess. All right? That's the first one. then the I we have to go m minus guess, because we go, yeah, minus guess minus 1 from here all the way to minus 1. And what we do is the h, we're gonna minus minus what? Minus I plus guess, right? So here, plus guess. Yeah, plus guess. I plus guess is this thing we're gonna remove, and remove this is gonna have to times power, right? That's what we do. Minus this times power. So that's the one we need to get rid of, and then plus nums1I, and we don't have the time power here. And then we can mod guess. Okay, mod I plus guess. Yes, because I is here. 1, 2, 3. Remove this and plus this. So that will be H. And we'll append I. Okay. So for J, it shall be the same thing, right? So J, we're gonna say, ooh, J, m minus guess, right? That's where we start. Minus 1, minus 1. And then while J is m minus guess, then we say J, ooh, N, that's not M, it's N. N. So it will be from J to N minus 1. Right? So that's the first one. And H2 will do the same thing. So it will be J plus guess multiplied by power plus this one J. No power. Mod. And the rest shall be the same. Try it. Lord, ain't right. That is not right. Why? Oh, I think I know. We remove this, and the whole thing has to multiply by power. Wait, do we need power? No, we don't need to. Hold on. So we have this, right? We remove this. Yeah, man, this one has to multiply by power. Oh my god, I have to multiply by power. Man, I am not sure. But still not right. Why? This is still right, no matter what. Hold on. I don't want to understand. Let's see. Print guess and nums1 hashes. I'm not sure what I'm looking at. Okay, let's do without the mod. This is kind of the first thing. Yeah, it's still not right. So it is. But I did follow. God. Yeah, this seems right. And everything's times. Oh, times p. It is p. There we go. Times p. All right, first make sure they work. Now let's try and mod it. All of this is just to avoid the very complicated thing. Okay, seems to be working. Note that the check goes from right to left. This way we can avoid division when computing the next rolling hash. Alright, let's just get this done. Come on. Show me something. Show me. Holy crap. Oh wow. Rolling hash is super duper fast. No, it is with mod. Jesus. OMN log. Wait, is OMN log or what's this? OM ON K O N K, right? This is N O N K log M maximum M N. Oh, this one. No. Well, what's the time complexity for this? Minimum. Yeah, this is a minimum. Oh, why you say maximum? Yeah, this should be minimum. Yeah, this is minimum. Creating a rolling hash is OM plus N. Well, that's OM, ON, but you have also these things. You just ignore these things, huh? You just ignore the cost of splicing. I think it's more than this. I think it's n plus n times something. Like times a, I don't know, depending on how many times this is called. How to say times a k? I don't know how to say the k. But anyway, all right, that's it. I was thinking about rolling hash. I mean, you say yesterday, or maybe this morning. Didn't really want to get into it, but well, we did get into it, so it's a good practice. It's a good practice. I don't want to get to this thing. I mean, what is this thing? I don't want to get into this part, which I think can be avoided if we use my method, right? Because they have to multiply something as well. See, they have to multiply something as well. So in my case, I go from right to left. So every time I minus this, this is the thing I minus. So it's some multiplication, and I times p, and then I add a single one. Then I can mod it. So division and mod doesn't work. But multiplication with mod does work, and this has proved to be correct. Can I memorize this rolling hash thing? I mean, it's not that hard to memorize, right? It's just a p and a power, right? A p, which is pick 113, and 0 power, 1 power, all the way to n minus 1 power, multiplied by the number at each position. You add them together. And when you're rolling hash, you just either minus the front, divided by p, and then plus a new value times the power, or you minus the last one, which is the value times the power, and everything times p, and then plus the first one. So it can go both ways. I like to go from right to left, basically. Alright, that will be it for today. I'll see you guys tomorrow. Adios.